Linear scatter plot. So it says an Italian ice shop in Chicago recorded its sales in comparison to the daily high temperature over a couple of weeks in June one summer. They recorded their data in this table below. Create a scatter plot from the data. Okay, so we have the temperature over 75 degrees, and we also have the sales. Okay, so on the x-axis, as you can see, we have our temperature over 75 degrees. On the y-axis, we have the sales. So our first coordinate point that we're going to want to grab is this 8, 1,400. So 8, 1,400, this would be this coordinate point. Now the next one we'd have to graph would be the 3, 1,240. So 3, 1,240 would be about here. And you're going to have to estimate on this quite a bit when you're plotting these points. And you don't have to be wonderfully correct. We're really just trying to get like a trend of where these dots are, because we're going to create like a line of fit. So 11, 14, 14, 11, 1,414. That would be like here, maybe. 12, 1,471. Maybe here. Okay, I'm going to try to go faster. 10, 1,291. 10, 1,291. Maybe here. 8, 1,312. 1,300. Maybe here. Even if I mess one up, it's really not going to change too much of the trend of the line. 13, 1350. That's exactly here. 7, 1,236. 7, 1,236 here. 5, 1,275. 1,270. 13, 1,417. It's fine. 9, 1,380. That's pretty good. 14, 14, 13. Well, 11, 1,340. 5, 1,208. Whew, okay. That's not always the most fun, just plotting points. Okay, but we have our scatter plot. Just a bunch of dots scatterly plotted on the graph. Okay, so we have our scatter plot. A says draw a line of fit. So a line of fit. Now, that kind of means like, you might have heard like a line of best fit. You're just trying to draw a line that like trends with the data. So if you look at the line, it looks like it's kind of slanting upward. So I want a line that goes through the data, like a straight line that kind of cuts the data in half. It looks like it's a positive slope, cuts the data in half, kind of equal amount above, below. That's what I kind of want to do here. And it's easier with a ruler, but I'm on a tablet here. So I think I have like a little line tool that might work. Okay, here we go. I'm going to try to do this first try. Okay, come on. Okay. I'm okay with that. That's a pretty good line of fit. All right. We're going to stick with that. I like that. Okay. Yeah. So you see what I kind of did there? I try to kind of split it right down the middle. It looks like I kind of have an even amount above and below. Like I'm just trying to, draw a line that kind of cuts that data. All right. Here we go. So what is the approximate y-intercept of my line of fit? So if I look at my approximate y-intercept, like, I don't know, right here, I would say that's at 1125. That's like right in the middle of those two. Wouldn't you say that? I would say so. So I'm going to say 1125. And yeah, so that's my y-intercept. What does it represent? So what do it represent? Because remember, this axis down here is the temperature over 75 degrees. So I would say, and this line of fit is used for predictions. So I would say, since it's 0 over 75, I would say at 75 degrees Fahrenheit, the predicted Italian ice sales, sorry for my handwriting, would be $11,125. Yeah, that's what it would represent. What is the slope of my line of fit? Okay, so let me pick a couple points here on the line. Now be careful with this because you have to pick points that are on the green line. You can't pick your the scatter plot points. You're trying to find the slope of the line. So typically to get the most accurate slope, I kind of want to pick points that are far away. So why don't I pick here? I'm going to use red just so it sticks out. Here I'll use this because that crosses nicely. And then maybe this one because that crosses pretty good too. And yours might be different than mine. I mean, it is what it is. So I'll calculate the slope. So the question is let's do rise over run. And you could write them as coordinates and use the formula. This would be 1,400. But I'm not going to do it that way. I'm just going to do rise over run. Okay. So let's see the rise. Looks like it's rising. Make a right triangle out of this. Okay. So it's going by 50s, right? So it's going to 1150 to 1450. So it's going by 50s though. So why don't I just count these by 50? So 50, can't really see how I'm counting this, but 50, 100, 150, 200, 250, 300. And you might have been able to do that in your head. 1450 minus 1150, that's 300. So the sales are going up 300, and then this distance here, this full distance, that distance, these are just going by ones in that in this axis down here. They're just going by one, so that's easy. So it's going from 1 to 14, so that's 13. But you can count if you want to count the spaces. 1, 2, 3, 4, 5. It's going that's 13 spaces. So it says, what is my slope? So rise divided by run, 300 divided by 13. And this is probably going to be a nasty number. Let's see what it is. 300 divided by 13. 23.076. Yeah, it's nasty. So I'm just going to round. I'm going to say approximately 23.1. If I round there, 23.1. I'm going to call that my slope. So that means our slope, remember, is 23.1. So this was like $300, right? That's our sales over 13 degrees Fahrenheit, right? That's what our units were on this. So that means our slope represents the sales will increase by $23.10 per degree. Let me just write degree Fahrenheit. Yep. So that's what the slope represents. The sales will increase by $23 per degree Fahrenheit. The slope. So the equation, and it doesn't give me any variables I need to use. I'm just going to use y and x would be in slope-intercept form. So the slope is 23.1. So 23.1 x plus 1,125. So that would be my equation, slope-intercept form. So it says, using the equation, what would be the expected Italian ice sales when the temperature is 92 degrees Fahrenheit? Now be careful because x is our temperature above 75. X is our temperature above 75. So this is 92 degrees is, if you do 92 minus 75, 92 degrees is 17 degrees above 75. So I'm going to use 17 for x. So I'm going to go 23.1 times 17 plus the 1,125. That's going to be 392.7 plus my 125, or 1,125. And I got 1,517. That would be the predicted sales at 92 degrees. And, quite frankly, we can double check this with our table and just kind of see if we're in the right ballpark. So for 17, we put in for X, right? 17, we put in for X. Let me just emphasize that. 17, we put in for X. And we got 1,517 as our sales. So if I go up to my graph and I look at 17, right? I look at 17 and I go up to here, see where it's at. And I kind of look over here. 1,517, is that what it was down here? Yeah, that's really good. Like, it actually kind of matches what our best fit line would tell us. So all makes sense. I always like reasonably think about your problems. So I'm going to let you do the other ones. Okay. So you draw your scatter plot, you make a line of best fit, you kind of estimate what your y-intercept is, and then you do rise over run and get your slope, write your equation, and that's how it works.